Go back and watch this later. But if you're looking for a local max of f of x, what are your candidates for local maxes? And that's it, right? I was pausing to hear if somebody was going to say and the other thing, but that's only if you have absolute, right? Yeah. So the only thing we care about are critical numbers. Guys, make sure you get this. I think you probably do. Since we're looking for critical numbers, those are places where what is happening? F prime. Yeah, f prime is 0 or doesn't exist. And are you guys comfortable with the idea that f prime not existing is not going to be a factor here? Because we got this nice, lovely cubic polynomial. I don't think we need to worry about f prime not existing. But we do want to be concerned with where f prime is 0. So did you guys put this? Listen, I don't want there to be frustration or sadness later. I hope you guys understand. I've told you this before. Writing the equals 0 part is absolutely essential. Because if you don't write equals 0, there is no equation that you could solve, which we're about to do. So you must write it. Don't think it. Don't say it. Don't feel good about it. Write it. And then feel good about it. Okay, that makes sense? Okay. Okay, so then how on earth are we supposed to solve something like that without a calculator? Factoring, or maybe the quadratic formula, or, God forbid, complete the square. I would be a fan of factoring as well. So 3x and x, and it would have to be plus 3 minus 1, right? Okay, so then x is equal to positive 1/3, and x is equal to negative 3. So are we done? Is that it? No. Have we accomplished something, though? Yes. What have we accomplished? We found some critical numbers. Those are our candidates, right? Okay. You guys do not have to do it this way. I am a fan of a little sign chart. I'll make an f prime sign chart, and I will be putting the negative 3 right about there and the 1/3 right about there. Those are my two critical numbers. And I've basically established 3 intervals. I usually color these. Green, red, green, red, and purple. Something different, right? Okay. So then what kind of a test value, because we got to test these intervals, right? What would you use? Or no? So maybe a different question?
I have a question later, but 0.
So yeah, so f prime of 0, that would fit in here, wouldn't it? Okay, so f prime of 0 equals negative 3. So that goes there. Negative 6, interesting. Why did you pick negative 6?
I just felt fun.
Just because? Okay, I'll go with it. F prime of negative 6. So let's see here. That'd be 108 minus 48. You got 57? 57. Whew.
Mental math.
Challenging. Now, you know, I do like mental math. Okay. And did you choose like 74.6 for the other one, for the purple region? No? I'm just kidding. I'm kidding. What'd you choose? 1 makes sense. 2/3, a little awkward. 2/3 would work. But yeah, I'll go with 1. I like 1. Okay, so 8. Yes. Okay, so you got this nice, lovely sign chart. We are not done yet. We need to tie this up with a justification. But your question?
So, like, technically from this, like, you could know that, like, the maximum is going to be at negative 3 because even, like, before you wrote out the regions, just because it's going to be, like, the bigger y value. But then, like, to justify it, would you need to use one that was on the other side of 1/3? Could you not just show the it's increasing as it's leading into?
Well, so that's a thing. So
decreasing out of it.
Now we're getting into the difference between relative and absolute. Mm-hmm. So, like, are you talking about how the fact that f prime becomes positive over here? So that means the graph of f is now going up?
Well,
no?
I'm just saying, doesn't that not really prove anything? Because, like, f prime negative 6 proves that it's increasing as it goes into hit, like, negative, where x equals negative 3 right here. And then f prime of 0 shows that it's decreasing after that. So, like, doesn't that prove that it's a relative max? Do you need to show that it, like, increases again later? Oh,
I'm sorry. So you're asking, do we even really need to put this?
Yeah.
No.
Okay.
Not at all. Not at all. That's more just force of habit for me.
Okay.
Yeah. Yeah, you see the pattern of f prime going from plus to minus, And if you just like mentally think, oh, wait a minute, I can tell for sure that f prime is going to go back to plus, you really wouldn't even need to put
Because
that.
like I did.
Agreed.
I
Agreed.
just did like found f prime negative 3 obviously 0, and then found like f prime negative 6 and f prime of 0. And
Yeah,
you were,
yeah,
like,
yeah.
far over.
Yeah, I think that's fair. Okay, so as far as justifications go, I'll put one up here. You can ask if you have a different one. So I'm going to say that f has a local max at x equals negative 3 because f prime of negative 3 is 0 and f prime changes from positive to negative.
Is that asking for the y?
It is. We'll get to that in a second. From positive to negative at x equals negative 3. You can say maybe like, therefore, the y value at the relative or local max is what? Negative 27. What is it? 14? 13. Hang on. So 27. Oh, minus 24. Oh, wait a minute. What am I doing wrong here? 27. Oh, yeah. You said it's 13? 13. Okay, cool. All right. I'll trust you. Question from Ah Young.
Does it matter in our, like, when we word it, does it matter if it's local or relative?
Those are synonymous. Either way is fine.
And do you have to state the first derivative test?
No.
Or can you just define it?
You can just basically use the hypothesis of it. It's totally fine.
So if I said f has a local maximum at, and then I said actual point, like negative 313, is that fine?
Yeah, that's great. That covers the x and the y value.
Do you have to state that it's continuous?
You don't. It doesn't have to be differentiable.
It just has to be continuous.
It does have to be continuous. That is the condition for the first derivative test. When we're doing these justifications, we don't often put that. The fact that you've mentioned that f prime of negative 3 is 0 and f prime changes from positive to negative, that's sort of our backdoor way into saying, oh, we're implying continuity with that.
Okay.
But yeah, continuity is a condition. All right. I'm seeing some fairly confident faces. Yes? No? How are you feeling? Questions? Concerns? Okay. Wasn't this one most similar to numbers 1 and 2 from our examples yesterday? Like sort of a generic function. It's not really an application at all. That's fine. You're welcome. We're going to do an application right now. Oh man, we're going to do two applications today. Okay, so if you guys would please check out, not that. How about that? All right, number 5 is where we are at. Guys, we're probably just going to do 2 examples today. And if we end up with some extra time at the end, which we might, depending on how things go, we'll just do another review question. We're not going to go any further or faster than we have to. So you guys would take a minute. Clearly, this is a paragraph. Clearly, this is a story problem, if you will. So you guys would please take a look here at number 5. I'll read it out loud for you. Calculator is active. I want you to really focus in on the details here once you get the sense of the story. So it says a local car dealership is receiving new cars from the manufacturer at a rate of R of T, measured in cars per day. The dealership is selling cars at a rate of S of T, again measured in cars per day. At what time on the, oh, sorry, there's a typo. At what time on the open interval? We don't need to have interval in there twice. At what time on the open interval from 0 to 10 is the number of cars at the dealership at a relative minimum? Okay.
So make C of T.
So yeah, you're starting to jump into some interesting things. I think kind of like we did with the word problems we did in section 2.6. I think it's a good idea to make sure that you understand the real basic plot of the story. Does it make sense? Anybody summarize it in like 7 or 8 words? What's happening in this situation? Go ahead, Anna.
Dealership is receiving cars, so like adding cars to the total
at the rate of R of t, and he's losing them at the rate of S of t. R of t minus S of t.
So yeah, we're getting into some good details there, but the basic plot makes sense. Dealerships getting cars and selling cars.
So how would you define like the basic, like in real life terms, what's the relative minimum give you? Like,
That would tell you, so like 0 to 10, that would be measured in days, right? So over a 10-day span, on what day would they have like the lowest number of cars at the dealership?
okay,
That makes sense?
okay.
So maybe that would be a day. So if they could quantify this and say, okay, we think this is going to happen, maybe that would be the day when they would ask the manufacturer, hey, we would like to have more cars on that day to change this equation.
Okay,
Does that make sense?
yeah.
Okay. Okay, so you got the basic plot here. Yes, basic plot? There are clearly some important numbers and equations and rates in here. I think it's really important for us to, just like we did with those related rates questions, let's identify what we're trying to find, and then we'll start picking apart the rates. So what are we trying to find?
Number of cars to minimum.
Okay, so specifically what kind of thing are we trying to find?
An x value? Or a y value?
I don't see any x's or y's up there.
Minimum.
The y value of the relative minimum. The t.
Come on.
The time that they have.
Say again, Andy?
The equation for the
No, like in the end,
value of the relative minimum.
there's no x's.
Technically, it's going to be
We got to break the habit of everything is x's and y's.
It's going to the t value. Of
The you guys see it? It's right here. At what time? Did you see it? At what time? We're looking for a time where we have a relative minimum number of cars. Make sense? At what time do we have a relative minimum number of cars? So we're looking for a minimum. All of you guys are like, we're looking for a minimum. Agreed. But in the end, we're looking for a time when that minimum happens. That's different than what the minimum number of cars is, right? Okay, so we just want to keep straight what we're looking for here. And it is sort of an X and Y thing, kind of like we did with that review problem a second ago. Okay, so what time is the number of cars at the dealership at a relative minimum? So this might be a good time as you start to attack this and pick it apart to think to yourself, and you guys I think are exhibiting that you're getting pretty good at this, you think to yourself, relative minimum. Gosh, a relative minimum would happen when what is going on? At a critical number. And what else about the critical number? Like what else are like around the critical number? And this is where we want to be a little bit less generic. We want to start getting a little more specific. You said the slope, and I would say the slope of what? What does F prime stand for?
Tangent line.
Okay, so the slope of the tangent line, agreed. But we got to be contextual here. We can't just say some slope of something or some tangent line. We want to be, okay, we want to know the slope of the tangent line, the rate of change of what? Of 0?
Okay, no, but like you want to know when
When the rate of change is 0, that's a critical number, right?
yeah.
But then what is, say it again, Sonny? We're not looking for the number of cars. We're looking for the time when the number of cars is at a minimum. I can give you some really good direct instruction and tell you exactly what to do. I want to hear your thoughts, though. Keep going. A relative minimum will happen at a critical number. Let's establish that is totally true. And what else must be true? Just because you have a critical number doesn't mean it's a relative minimum. You also have to have some other things, conditions that are met. You got a critical number and something is changing.
RT minus ST.
Say again?
RT minus ST.
You're getting, so we are going to be using those, and that actually is, I think, a pretty good relationship. We haven't really defined what C prime is.
Should you state that now?
She made this.
We can. I'm looking very conceptual here, guys. Think this over. Hey, listen. Let's back this up a little bit. If I'm looking, I'll be real generic here. If I'm looking for a relative minimum of F, and I know there's no F's up there, but we're being real generic. Looking for a relative minimum of F, and I know that there's a critical number in there somewhere. Not only do I need that critical number to have a relative min, F prime, which is the rate of change of F, must be doing what?
Increase, changing from, or
Decreasing
decreasing.
change must be equal to 0.
Ooh. Okay, let me write this out.
Well, to find the critical
He's
number
having
for
a
what?
hard time.
F prime must be what for what?
So, guys, We're starting to use some, and this is, hey, I'm making up some generic function. We'll try to apply it to this here in a second. You guys got to realize this happens almost every year. We're starting to go a little bit off the rails with two sets of words, negative and positive, and decreasing and increasing. We're using them very generically, and we need to be real careful about that. So let me just give you a generic argument here. F of x has a relative min at, we'll just say x equals 7, because f prime of 7 equals 0. What does that prove?
It's a
A critical number at 7, at x equals 7. And f prime changes from,
negative to positive.
there it is. If we were to say these,
You
this
have to say
is,
that instead of
That's
prime.
but you can't really do that. You have to argue based on f prime. You have to argue based on f prime here. And so if I were to replace negative and positive in this particular situation with those other words, I would be completely talking about the wrong thing. I'd be talking about f double prime changing from negative to positive. That's something totally different. So you want to be really careful. You don't want to let any detail go uncovered. So let's do this. You guys just did this a second ago with that really generic warm-up. Does this make sense now? You know what's interesting is, you guys were actually, I think, really darn good at that. There was a few little hiccups, but for the most part, we were really good. We start reading about a car dealership and cars, and all of a sudden we're like, I don't think I understand the first derivative test anymore. Did you see how confusing that was? So we want to be super careful that these big concepts don't get messed up just because we're talking about stuff like this. The concepts are the concepts. They don't change. The context absolutely changes, for sure. Okay, so based on this, we are looking for a time when the number of cars is at a relative minimum. That's going to happen at a critical number. It's a critical number for something. And it would happen when the rate of change of cars does what? There it is. Changes from negative to positive. Okay? You will have a relative min of cars when the rate of change of the number of cars, goes from negative to positive. Just like you'll have a relative minimum for f at a critical number whenever f prime, which is, isn't f prime the rate of change of f? Yeah? Whenever the rate of change of f goes from negative to positive. That concept has not changed. So, let's do this. Let's get rid of all this generic stuff. If we have this okay, we'll see. So if we are looking for a critical number for the number of cars, and we're looking for where the rate of change of cars, you listening? If we're looking for a critical number for the number of cars, and we're looking for the rate of change of the number of cars, we probably should establish what the rate of change of the number of cars is, right? Do we have some rates going on? What rates? Yeah. And they even use it. How do you know that they're rates? I mean, it says it right there. Rate. Rate of R of t measured in cars per day. Rate of S of t measured in cars per day. So those are two different rates, and this is where you guys were starting to come up with some really good ideas. What would be, we have two rates. Have you guys figured out this is the water tank question?
Yeah.
It's just cars. You have the rate of cars flowing in, and you have the rate of cars flowing out. This is a water tank. It's just cars instead of water. So R of t is the rate of cars flowing in. S of t is the rate of cars flowing out. And you said it earlier, R of t minus S of t? Absolutely. So you could, depending on how you define that, and you don't even really have to do that. If you just wanted to do this, R of t minus S of t, and then since we're looking for critical numbers, you could just go equals 0. And if you wanted to call that C prime, you totally could. There's no rule that says you have to do it that way.
Justify it in this thing or no?
We'll justify ourselves for sure.
So then wouldn't you
On a test, I'll be very clear. If I wanted you to justify yourself, I'll probably put it in bold letters. Justify your answer. Here in class, we'll probably always justify ourselves, just so we get the practice.
How would you justify that without naming it? Because you couldn't say
Justify
C-
that?
Well, I get justifying that, but how would you say that
Oh, I'll show you.
C prime of t changes from increasing to decreasing?
I'll show you. Oh, no, C prime of t would change from negative to positive. I'll show you, Anna. Anna, I'll show you in the end. Okay. So, are you guys okay with that? You guys were wanting to jump to this pretty quick, and that's great. I'm glad that you saw that. Do you have any questions on what I've done so far? Yes, ma'am.
Okay, so we're making up a function to determine the number of cars,
would you put that C equals RT?
You
minus
don't, so you don't have to do what you're saying. So like last time we made up a function A of t or W of t for the amount of water. You can totally do that. You don't have to do that though. Like if I wanted to, I'll erase this here in a second because I'm going to choose to just do it this way. But I could have said, hey, C stands for the number of cars at the dealership.
Okay.
I could have said that. And if C stands for the number of cars, then R of t minus S of t would not equal C. It would equal C prime.
Okay. And if you name it like that, then can you do in your reasoning?
Then you could do what?
Like in your reasoning, could you say C of T?
Of course. Yeah, as long as you define what it means.
Okay.
But let me show you how you could do it without that. So I'll erase this stuff right here. I'm looking for critical points. I've got this R of t minus S of t. So this is ln of t plus 1 minus 3 sine of t over t, and then plus 1 equals 0. It's definitely calculator active, right? Please use your calculator to solve that equation. Find the 0 on the interval from 0 to 10. There, I think there's probably just the 1 0. There might maybe there's 2. I don't know. Are there 2?
No, you don't have to take the derivative of it. It's
Oh, let's talk. I was wondering if somebody's going to ask about that. Hey guys, listen. It's going to be super tempting to differentiate R and S. No, but here, guys, listen. You got to, please, really, I could draw some stuff on the board if I need to. You guys, you've got to really listen to my words right here. I'm going to choose them very carefully. To find the relative minimum of the number of cars, you want to set the rate of change of the number of cars equal to 0. Does that make sense? Aren't R of t and S of t already related to the rate of change of cars? So you don't. So in other words, those are already the derivatives. Those are already the rates of change of the number of cars. It's going to be real tempting to think this. I'm in a calculus class. The derivative is a thing that I do sometimes. And so I better be doing it every time I do a question, right? So what's challenging about this is not the finding of the derivatives mechanically. It's the finding of the derivatives visually and saying, that's a derivative, and so is that. Therefore, I don't need to do the mechanics of finding a derivative. Somebody already did it for me. I just need to identify it. Does that make sense? It's so tempting to just want to differentiate everything you see, right? But those are already the rates of change of the number of cars. So I don't need to do any of that stuff. Anybody solve this equation yet? What'd you get? T equals what?
Oh, not for T. So never.
Yeah, you guys should be, please, I don't have these answers memorized. You all got calculators. You should know how to do this. Should be rolling. Come on. Daylight's burning.
okay. Quick question, just for review on logs. So like, say for example, if this was like, because ln is like log base e. So if this was log e of 5 equals 4, would that be e to the 4th equals 5?
Mm-hmm. I think of it as rolling the log.
Okay.
E to the 4th
So then
equals
this
5.
would be.
Use your calculator, my friend. Use your calculator.
Ow.
Is it like math?
Like, no. On your, go to your y1 equals y2 equals, go like your little equation editor.
Yeah.
And in your equation editor, put ln of t plus 1
Oh.
minus.
I didn't know we were-
I got to put parentheses on here. Sorry.
I don't think.
Wait, do you not graph?
You what?
Wait, do you graph it?
Yeah.
Okay.
Oh, I thought you were like
Graph it in-
solve for it, and I was like.
Well, no.
solve it
Listen,
by graph.
graphing it and finding the zeros, that's solving it,
Okay.
right?
I was like,
Graphing the expression on the left.
But
And
no, we're not allowed to do that.
no, you totally can. What you can't do, you cannot use the max min function.
So bad.
Oh,
You cannot use the max. You know, like
all right, yeah.
second calculate max or whatever. Well, you're welcome to do that, but if the reasoning is, hey, I use the max finder and here's the max, I'm going to be like, sweet, no points.
But you can do that to do like the math for you, but then you just underneath it.
Yeah. Yeah, definitely use the zero finder. You can also use the intersection finder. That's another thing you can do. Come on now. What do you guys got? 1.549? Let's get some confirmation on that. I don't have this memorized. 1.549 is what Eden said. Anybody have a confirmation or a you do? Brendan agrees. Let's get one more person to say that yes, that's right.
Yeah, I'm getting a 2 number. I got 2.2.
Did you put? Are you guys putting parentheses in there or not?
Yeah, I got 2.2.
Did you put the 3 sign, like all of 3 sign of x in parentheses?
I think I got 2 point.
Parentheses.
What did you get?
I think I got 2 point something.
2 point something. Yep. So the majority of people are saying 2 point something. Brendan is now saying it's 2 point something. Give me the 3 decimals. Let's be consistent. 2 point what?
817.
817. Okay. All right. So that right there is the critical number. That is where the rate of change of cars is 0. And by the way, if for the last few minutes the whole solving by graphing and finding zeros, if you're like, whoa, I do not know how to do that, like that would be considered a very basic tool in your toolbox. You need to know how to do that. So if you need to know how to do that, come see me during a business lunch. I'll show you. We'll make a video together, and I'll post the video, and you can always go back and watch that later. There's probably 10 million videos on YouTube already on how to do that. You need to know how to do that. That is imperative. Okay? So, this is where you guys have a significant advantage of having this calculator in front of you. Could you go back to your graph, Marguerite?
Yeah. I don't think my graph's right. So I got like 2.16.
Oh.
But I think I know.
Okay, so if we looked at the graph here, we can figure this out pretty quick. Can I peek at somebody's graph? Okay, that's pretty similar. Okay, you're good. So, Marguerite, I think your graph looks pretty similar. It's just shifted over, kind of funny. Did you guys get that graph? For R of t.
It crosses the x or the y-axis a little bit.
Sure, but I'm only really caring about 0 to 10.
Okay.
Okay, so guys, here's how you finish this. And this will kind of come back around to your original question about how do I handle this without this nice C prime thing. So here's what I would say to justify this, because I'm ready. I've got the graph in front of me. I'm ready to justify this. So I'm going to say that the number of cars is at a minimum when t equals 2.817 because R of 2.817 minus S of 2.817 equals 0. Right? That establishes that 2.817 is a critical number. And R of t minus S of t changes from what to what? Seriously? Changes from what to what? Negative to positive. There you go. Negative to positive at t equals 2.817. That tells me, going back around to the start, that the number of cars is minimized at that critical point. Question?
So let's say I said like the whole equation was equal to C prime.
Yeah.
Can I just say C prime instead of filling in?
Yep.
Okay.
So yeah, so wherever I have R of t and S of t, RT minus S of t, you just have C prime. Totally fine. So I wanted to show you an alternative to what I showed you the other day. Your way works great. Totally. Anna, your question? Or did we got it? Okay. Yes, ma'am.
So for evidence about when it changes from negative to
Yes,
positive, earlier you did the first test.
We did this. This is the first derivative test still. The first derivative test is showing that the first derivative changes from positive to negative or negative to positive. Or, here's the thing. You've got a calculator, and I'm assuming you know how to graph.
Okay.
That makes sense?
You're just assuming that I read the graph.
I'm assuming that you had the graph in front of you, and you're like, oh, look, negative to positive.
Okay.
That's totally okay. It's when you don't have a calculator, kind of like we did with our warm-up, when you don't have a calculator, and you're just going to be like, hey, something changed from positive to negative. I'm like, well, how do you know?
Okay.
There's no apparent reason for you to know that. You got a calculator, I'm going to assume you know how to read it, and there you go.
And so he sketches that just like
just to show you.
We don't have to sketch it.
No, you don't have to sketch it at all. I just wanted to make sure that we all had the same looking graph and that made sense.
Thank you.
Okay, what do you guys think? Any questions? All right, so that took quite a bit longer than I thought. The whole calculator thing was a little perplexing to me. So I'm going to do my best here. I really want to finish this one, but I don't know if we're going to have time. We'll see. So if you guys would, let's take a look here at our final little piece of the puzzle, and it's velocity and speed. Like I said, I'll do my best to get through this, and we'll just see how this goes. I don't know, we might have a shot. We're going to do a lot more calculator work, and I'm going to support you guys a little bit more with your calculator work. I think that would be helpful. Guys, here we go. Velocity. We've talked about velocity before. I think we've talked about speed before. I might be mixing things up. Anyways, velocity is this. It is displacement over change in time. You could also say that it's like position 2 minus position 1 over T2 minus T1. Somebody might say, hey, it's how fast you're going or something like that. Velocity, though, if you've been in a physics course, you know that velocity is not just about how fast you're going, it's also about what?
Direction.
Your direction as well. So this is going to indicate both. And for us, we're only going to be dealing with things moving in one dimension, just left and right, or maybe up and down. And so the direction of it, the direction component of it is going to be a positive or a negative sign. Negative for us is going to mean going left. Positive would be going right or up and down correspondingly. Speed is not a vector. Like the thing you have in your car called the speedometer doesn't have any like negative numbers on it, right? Like if you put it in reverse, it doesn't go negative. In fact, if you put it in reverse and go, the speedometer goes up, doesn't it?
It's just the absolute.
Yeah, there it is. Speed is the absolute value of velocity. Speed is the absolute value of the velocity function. So these are both pretty useful things. And that's what goes in the blank here. Speed is the absolute value.
So if something was like ever asking for the speed of something, and you said like 20 miles per hour, and then like that would be the answer. But like if you just like added like in the negative direction, but didn't put negative 20 miles per hour, would it still be?
Please put negative 20.
Okay.
Like that would probably be acceptable. It's just awkward. It'd just be out of the norm. I don't know about awkward. It'd just be out of the norm. Okay, so I have so we might end up doing example 6 tomorrow. I thought we'd have more time, but we don't. We'll just see how this goes. I have a really high-tech demo for you, so pay really close attention. I'm being facetious when I say high-tech. So speed is increasing when? So I want you guys to picture, hey, this will help you, I hope. I want you guys to picture the front of the room like it's sort of a number line, and I have the convenience of having this lovely firewall in this room. So can you guys picture this firewall as like a number line? So for you, would you guys agree that that way would be a positive direction? And that way would be a negative direction? Okay. So I'm going to be like the particle, right? You have all these particles moving left and right or whatever. I'll be that. So if I am walking this way, my velocity is positive, right? I'm walking the positive direction, yes? And if I'm walking this way, my velocity is negative. You guys okay with that?
Yeah.
Okay. So if I do this and then I start to run, would you say my speed for that part was increasing or decreasing? Increasing. So I was like going a positive direction, my speed was increasing, right? Okay. So what if I start here, and I'm going to try not to trip. What if I start here and I start walking backwards, and then I start doing this? For that stretch right there, my speed was increasing. But what's weird though, wasn't my velocity negative? Which sometimes people will get a little bit confused about. So let me give you a principle here and then I'll try to illustrate it. Speed is increasing when velocity and acceleration have the same sign. Velocity and acceleration having the same sign means that speed is increasing. So what would you guys guess would go along with speed decreasing? When they have different signs. Yep, so velocity and acceleration have different signs. Okay, so again, a little demo. Most people will get this first part. So if I start off, let's say right here, I just want you to call out the sign of my velocity. Okay? Positive, right? Okay, what's the sign of my acceleration?
Positive.
So my velocity was positive, my acceleration was positive, I sped up.
Yes.
Okay, so you're going to have to be quick on this one, because I'm really quick. I'm kidding. Okay, so call out the sign of my velocity first. Acceleration. Make sense? So positive velocity. Acceleration was back that way, so I was slowing down. My speed was decreasing. Does that make sense? Where this gets tough, and I don't know if I want to do this backwards. I'll try. So call my velocity. Acceleration. Wrong. I sped up, right? Did I mean, I know I'm not that fast, but was I not speeding up there?
But it's because you have to have the same sign.
So my velocity is my acceleration negative, therefore right in there I was speeding up. Does that make sense? Say again?
Why would your acceleration be negative?
Because my acceleration was that way. Hey, think about it like this. If you guys drive, think about it like this. Picture a car. Picture a car. So pretend I'm a car now. So I know. Never mind. I was going to make a comment about my own self, but never mind. So if you have an automatic, let's say you have an automatic, you put it in reverse, right? And you know that if you just idle the car backwards, in reverse, it'll go backwards, right? Without you even pushing on the gas pedal, right? So my velocity is negative. Now remember, you're in reverse. So right about here, you hit the gas, and you start going faster that way, right? What is another name for the gas pedal?
Accelerator.
So when you push on that pedal, it will accelerate you in the direction that you're going. Make sense? So if I am in reverse, that has established my direction, right? And when I hit the accelerator will cause me to accelerate in the direction that I've told the car to go. So in a case like that, yeah, my acceleration would be negative. And because my acceleration was negative, at the same time my velocity was negative, I am terrifyingly speeding up going backwards. Make sense? Well, let's say that you are going really fast backwards. Check this out. So I have hit the gas going backwards. I'm going really, really fast. And I want to stop. Which way was my acceleration right in there? Positive. When you hit the brakes on your car will give you an acceleration the other direction from which you were going.
Just speed down.
Hold on. You're packing up for some reason.
To unspeed.
Hang on. You guys get this? Is this making sense? Okay. So, like I said, I was hoping we'd finish this by today. Whatever, we didn't. Come ready with your calculators tomorrow. The first thing we'll do tomorrow, and maybe it'll be the second thing, is we're going to tackle number 6. There's a little typo on number 6. It's not really a typo. I just forgot that we hadn't covered e to the negative t yet. I'm going to need to change that, but we'll do a pretty interesting exploration with that concept with number 6 tomorrow, okay? I think there is an intro video for tomorrow as well, so make sure you guys get that done. Be checking your Schoology. I will see you then. Have a good rest of your day.